Hello everyone. Welcome to the solution of LeetCode problem 554 named brick wall. In this problem, we are given a rectangular block wall in front of you which has n rows of bricks. The ith row has some number of bricks, each of the same height. That means 1 unit, but they can be in different width. The total width of each row is same. So here we have to draw a vertical line from top to the bottom and cross the least bricks. If your line go through the edge of the brick, then the brick is not considered as crossed. We cannot draw a line just along one of the two vertical edges of the wall. That means we cannot draw a line here in the first edge or in the last edge. In which case this line will obviously cross no bricks. So here we are given a two-dimensional array wall that contains the information about the wall, and we have to return the minimum number of cross bricks after drawing such a vertical line. So here, if we see these bricks, this is one bricks, this is one bricks, this is one bricks, this is one bricks. Now, this brick size is 1, this brick size is 2, it is 2, it is 1. So if we draw the bricks in these positions, we can see that these bricks and these bricks are breaking. So here, the answer is 2 because there are 2 bricks and other bricks is growing to the edges, or the line is going to the edges of the other bricks. So here we can see that for this test case, the output is 2. I hope you understood the problem. Now let's move on to the algorithm. For the simplicity of the algorithm, we have taken the first example here. The first example has 6 rows, where in the first row, the first element is 1, where this means that this first block, its width is 1. Now, the next element is 2. This means this next block has width 2. Now, this element is 2. This means this block has the width of 2. This element is 1. This means this block has the width of 1. So now, this is the information of the block are given. So we have to draw a vertical line. We cannot draw a vertical line here or here. If we do so, it will not cross any other blocks. So what is the optimal strategy to draw a vertical line where this vertical line cross the minimum number of blocks? So suppose if we draw a vertical line here, then the number of blocks we are crossing will be minimized, because if we draw the block line here, then the number of blocks we are crossing is this block and this block. So here the output will be 2. So now we have to determine what is the optimal strategy to draw the block line. So here, to solve this problem, we are taking the map data structure and we are using the cumulative sum. Suppose, let's see, currently we are at the first row. So here, the first element is 1. So our cumulative sum value is 1. That means we can write a block line into the edge of the first block, right? So wait, this is fine. Now our next element is 2. So our cumulative sum is 1 plus 2, which is 3. That means we can write a block line into this 3 unit width, right? Okay, fine. Now our cumulative sum is 5 for this element too. So here we can write a block line into these positions where the width is 5, which is 1 plus 2 plus 2. So we can observe that each of the block line we are drawing is connected to the cumulative sum. So for each of the corresponding row given in this input array, we have to find the frequency of the cumulative sum. Suppose for this first block, the first element is 1, so we have to mark 1 here. Second element is 2, so the summation is 1 plus 2, which is 3. So we have to add 1 here in the 3 positions. The third element is 2, so which is 5. So we have to add 1 here in the 5 positions. Now wait, should we consider this last element 3? No, we should not consider this last element 3 because we cannot write a line into these last positions. It is strictly prohibited. So we will not consider any of the last positions of the given input. Now for this element 3, we have to put again, add 1 frequency here into this element 3. For this element 1, the sum will be 3 plus 1, which is 4. So we have to put 1 here in the 4 positions. Now we are simply ignoring this element 2. Now for this element 1, we have to put a frequency 1 here. For this element 3, we have to put the frequency of 1 into the 4 because 1 plus 3 will be 4. Now for this element, we have to add frequency of 2, 1 here. For this element 3, we have to put the frequency of 1 into the 3 positions. And for this one, we have to put another frequency 1 at the 4 positions. Now, for this element 1, we have to put a frequency in the 1 positions. For this element 3, we have to put a frequency in the 4 positions. And for this element 1, we have to put the frequency into the 5 positions. Now, we have to calculate the maximum of all of the frequencies. So here, we are noticing that the frequency of 1 is 3. The frequency of 2 is 1. The frequency of 3 is 3. The frequency of 4 is 4. The frequency of 5 is 2. So what is the maximum among all of them? The maximum is 4, which is the frequency of 4. That means if we write the line, it will touch the edge of 4, which is the optimal. So where the edges are this here, 1 edge, 2 edge, 3 edge, and 4 edge. So here, this number 4 represents these 4 edges. So if we write the line straight from top to bottom, what is the number of blocks we have to break? We have to break 2 blocks. One is this, another is this, which is exactly 6 minus 4, which is 2. So 2 is the final output. So now I am wrapping up the entire algorithm. In short, for each of the row, we have to calculate the frequency of the cumulative sum except for the last element. After that, we will find the maximum and subtract this maximum value from the number of row, and we will get our respective answer. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function list bricks and the 2-dimensional grid. Now we are taking a map which will store the value in the key value pair. Here key is an integer and the value is an integer. it will be used to store the frequency of the cumulative sum. Now, for each of the row, initially the sum value is 0. Now, we will run another nested loop for each of the row and to calculate the cumulative sum for each of the element. If our current index is not the last positions, that means we have to upgrade the corresponding sum to our map. Finally, we will check the maximum of the corresponding map and subtract this maximum value to the given input n, which is the number of rows. So we will get the answer. I hope you understood the code. Now let's move on to the time and space complexity analysis of this program. In this program, the time complexity is big O of n square because we are using nested for loops, and the space complexity is also big O of n square because in the worst case, the size of the map can be equal to the size of the input array, which is a two-dimensional grid. So here, in the worst case, the space complexity is also big O of n square. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.